Hello and welcome to today's session where we are going to discuss about cloud design patterns for modern applications. So today I would like to introduce you to the fascinating world of cloud design patterns. As we increasingly rely on cloud computing for our digital needs, understanding these patterns become crucial for building scalable, resilient and efficient applications. In cloud computing, an array of architectural patterns awaits exploration. Among these patterns, we have carefully selected a collection of renowned design patterns like gateway aggregation, sidecar pattern, ambassador pattern, and circuit breaker pattern. Concurrently, we will delve into tangible illustrations and practical use cases to enhance our understanding. So let's get started. Before deep diving into the topic, let's take an example of a typical point of sale software, which contains some important modules like employee management, sales management, inventory management, payment process management, and reporting service. All the modules are interconnected to each other and using a typical relational database, which is acting as the main database here. Here we can see all the modules are under the same hood, means the software is a complete package here where all the modules are tightly coupled with each other. Moreover, if we consider this POS software is running in the web, then this follows a server client architecture, right? So to access all modules, employees or users need to connect through a single URL like this. This we called monolithic architecture. In fact, this system demands a handsome server configuration like bigger storage, larger memory, and powerful processor, which anyway at the day end attracts more cost. Then what we have seen in monolithic architecture, all the components are functionalities of an applications are tightly coupled together, forming a single entity. This traditional approach has been there for many years and has powered numerous successful systems in almost all domains and sectors. However, it is important to acknowledge that monolithic architecture does have its own limitations. Say, if this POS application grows in size and complexity, maintaining and evolving it becomes more challenging. A change in one component might require the entire application to be redeployed, which can cause downtime and inconvenience. Additionally, scaling a monolithic architecture can be difficult as it may require scaling the entire system even if only a small part of it experiencing high demand. What is the solution then? I think we can clearly notice a drastic change in the diagram as compared to the previous one, right? What we did, we have segregated all the modules from the previous POS system where each module running independently in separate instances. Here, instance means we can think of a container or a small sized server. The same employee or users are now communicating each module through different URLs or endpoints. So we have seen all the modules are running independently, which may look more complex than a typical monolithic design like the previous, but can be easier to maintain or update the functionalities. Also, we don't need costly server here since each instance is responsible to cater only one module, right? Thus, we can rely upon small and low cost instances. Industry calls this as microservice architecture, which is widely used in the cloud. In recent years, there has been a shift towards more modular and distributed architectures, such as microservices. These approaches offer greater flexibility and scalability. allowing different parts of an application to be deployed and developed independently. Well, cloud design patterns are strategic solutions to common challenges in cloud computing. Design patterns optimize scalability, reliability, and security of the applications. I want you to highlight the main benefits of incorporating cloud design patterns into application architecture. Cloud design patterns enable agility, allowing application to adapt and scale as required. They also enhance resilience, ensuring continuous operation and disaster recovery. In short, by adopting cloud design patterns helps organizations to build robust, scalable, and cost-effective applications. So let's move on. So our first part should be gateway aggregation that we are going to discuss now. Gateway aggregation pattern is a design pattern that combines multiple modules or entry points into a single interface, making it easier to access and interact with various services. Using an API gateway for consolidating service providers benefits such as simplified access, centralized management, and enhanced security for interacting with multiple services through a single entry point. Let's see an example. Let's consider the same POS modules as employee management, sales management, inventory management, payment process, and reporting service. Since we are discussing cloud design patterns, so we assume all the modules are running in different instances, following the rule of microservice, which we discussed earlier. Okay. Well, just one extra module we have introduced here named as Gateway API. Now, the same employee or users or maybe clients sends a request as follows, like HTTPS followed by the API address /employee. Then Gateway API treats this request only for employee management module and forward the request there only. Similarly, if the request contains as API/sales like this, then Gateway API treats only for sales management module. Same goes to inventory as well, right? So what we have understood, all requests comes through the Gateway API first, and then based on the request route, Gateway decides to reroute the request in all applicable modules. The end user actually feels that they are working in a single unit. In fact, if we want to secure the entire system, then we need to secure the gateway only. Means we can use the gateway for authentication and authorization purpose as well. When implementing a gateway aggregation solution, we should consider some key aspects like handling scalability and performance requirements, implementing proper authentication or authorization mechanisms, and implement fault tolerance to ensure reliable service aggregation. Please note this fault tolerance keyword. We shall discuss this in detail later in this session. Let's see who is utilizing the power of gateway aggregation in real world. Amazon API Gateway is an example of the gateway aggregation pattern in action. It provides a unified entry point to access and aggregate multiple backend services or APIs. It offers features like request routing, authentication, caching and transformation, allowing to modular services into a single interface. Let's move on to the next part, sidecar pattern. As a definition, we can say additional independent process known as the sidecar, which run alongside a main application to provide such supplementary functionalities or services. Say, in an instance, one of our module is running which has been built using .NET 6. Okay. Now, this module needs to write logs time to time to a file or maybe in a volume. Or maybe this module needs some specific but common configuration details like database addresses, third-party API endpoints, etc. So the common functions like logging, feature, and the configuration section we can set in a separate container, which actually runs alongside the main .NET 6 application container. Well, this is Sidecar. This can work like plug and play feature. It has nothing to do with the main application framework. Like we can use Node.js or maybe Python instead of this .NET 6. All we need to do just plug the sidecar alongside with this main application container, and that's it. We are ready to use. So we can say sidecar pattern extends the capabilities of service by separating additional functionalities or services into a separate process or container, allowing them to run independently and provide support or enhance the main application without directly modifying its code or impacting its performance. All set? Let's have an example. Remember, in previous example, we have seen gateway API was communicating with the other modules, right? So again, if we can remember, we have modules like employee management, sales management, inventory, report service, etc. Right? Now, in this existing POS system, to demonstrate this sidecar example, let's take employee management module, which is running inside an instance since they are using microservice pattern, right? Suppose this instance running in Linux platform, for example, Ubuntu, and the instance IP is showing like 192.168.0.110. Inside the instance, we are having our main employee module application, which has been deployed with .NET 6 and hosted in the main container. Alongside, we have added Nginx service, which will act as reverse proxy for this main application container. Now, one request comes from the user or client as HTTPS followed by the instance IP /swagger/index.html. This request first goes to Nginx. Nginx will forward this request to the main application container with the local address as HTTP followed by the local host with 5000 as custom port /swagger/ the same index.html. Now, this main application processes the request and sends back to Nginx. Further, this send back to the client, and finally, client can see the main page. So here Nginx is running alongside the main application container and acting as a sidecar. We have observed sidecar pattern offers advantages such as modular and independent functionality, scalability, and easier maintenance. It is useful in scenarios where we want to add or modify features without altering the code application, handle logging or monitoring, or integrate third-party services seamlessly into the system architecture, like this example. When implementing the sidecar pattern, it is important to consider factors such as communication and coordination between the main container and the sidecar container, ensuring proper resource management and handling potential failure scenarios. Though few challenges may arise from maintaining consistency between the main application and the sidecar, managing the life cycle of the sidecar process or container. Being said that, let's see in which industry sidecar is used most. Istio is an open source mesh platform utilize this sidecar pattern very well. They deployed a sidecar proxy alongside each service instance to provide features like traffic management and observability, and of course, without modifying the core service. So, let's try a simple question. Can we use gateway integration with sidecar pattern? Your time started already. I am expecting some answers. 5 seconds remains here. Good. So I have received 100% yes. And of course, yes, we can use it. We can use it alongside with the gateway aggregation. So let's move on to the next slide. The ambassador pattern. Like Sidecar, the ambassador pattern relies on two containers that are co-scheduled. Here, the interactions between application container and external services are managed by an ambassador container. Well, sounds complex. Let's see an example again. From the same POS system, let's take three modules: payment service, sales management service, and inventory management service. Suppose more often these three modules need to use a third party payment service for sale or purchase. Now, to communicate with third party payment service, obviously we need to implement security. Also, we need to use the payment APIs to integrate. What else? Well, we need one more thing, that is monitoring service, which will monitor the entire payment process whether the payment succeeded or failed. Right? If we think these three services as a sidecar, then we need to add all these three in each module. Correct? Or else we can do one thing. We shall wrap these three services into a common container. We call it as payment process management service. This is the ambassador, where all the main modules will communicate independently and rest will be taken care by the intermediate container itself. So based on the example we have seen, the ambassador pattern simplifies the network related functionalities by centralizing and abstracting tasks such as security, routing, monitoring, and load balancing, allowing services to focus on their core functionality without worrying about the complexities of network communication. This pattern is commonly used in such microservice architectures and cloud-based systems, especially where we need to handle cross-cutting kernels such as third-party payment service, network traffic monitoring, etc. As we saw, it provides benefits such as improved scalability, flexibility, and of course, simplified maintenance of network-related functionalities. Then, let's see where this pattern is being used the most. Kubernetes, the well-known open container orchestration platform, uses ambassador pattern through the Kubernetes ingress resource. The ingress acts as an ambassador, managing external access to services within the Kubernetes cluster, handling load balancing and routing based on rules that is defined in the ingress resource. Let's move on to the last one. This is the pattern that I am going to discuss is the most trickiest pattern in today's discussion, the circuit breaker pattern. Circuit breaker pattern acts as a safety mechanism that helps prevent cascading failures by monitoring and controlling the flow of requests between components. Components means I want to say the containers as well, maybe the instances. When a component or service or maybe the instance experiences a failure or become overwhelmed, the circuit breaker trips. Yes, trips and temporarily stops forwarding requests to that component. I would like to draw your attention to this diagram for a while. See, here are three states, right? Closed, open, and half open. Please ignore all other arrows and text. For this time, I'll explain all these three things which already mentioned. So, circuit breaker acts as a monitor service between a communication channel. so that if communication goes well as a happy flow, then circuit breaker state is considered to be closed. Otherwise, if communication breaks, that time immediately circuit breaker sense it and trips. This is the open state. Then what is half open? In the half open state, the circuit breaker typically allows a small number of requests to be passed through, such as one or a few, while monitoring the response. If this request succeeded, then circuit breaker assumes that the service or resource has been healthy and become live again. And then it moves directly to the closed state, allowing normal request traffic flow. However, if any of the requests in the half open state fails, then the circuit breaker moves back to the open state, indicating that service or resources is still experiencing issues or hasn't fully recovered. Now, where we need this? Say, when calling an external API or a database or a network service, it can be used to handle situations like timeouts, network errors, or excessive load by providing a fallback mechanism or temporarily halting the request to prevent further degradation of the system. Question is how? Again, let's see an example. Well, remember our POS system? There was a reporting service, right? So say suppose this is the reporting service. For example, let's take this module only. Many users or clients are trying to invoke some reports from the system, assuming that this reporting service is supported by a main report repository application. This repository application communicates to the database container to collect and process data further. Here we have added cache service and the circuit breaker service into this repository. In current scenario, requests and response are functioning properly. Hence, in this happy flow, our circuit breaker is closed state, right? Now, suppose the database container goes down due to heavy traffic, like this. Then, obviously, our circuit breaker detects a communication failure and will try to establish the communication for one or few times. This threshold actually depends how we have configured our circuit breaker timeouts. Now this state we can call as half open as discussed earlier. Say suppose the circuit breaker cannot re-establish the communication with the database container. Then what will happen? Well, it is very smart to handle this kind of fault. It then sends back the last cache data as a response like this. This way, it temporarily handles the failure or timeout problem to the client segment. Not only that, but it also starts a new database service discovery at the same time. Now our circuit breaker, say suppose found this database container service. This is maybe you can consider as another instance of database. Then circuit breaker will try to communicate with this database container and try to establish the connection again. So the connection has been active. Voila, the happy flow is actually going on. In this scenario, circuit breaker removes or revokes this cache service. So again, we can see the happy flow is currently going on and the state is again closed. Now, when implementing circuit breaker pattern, some important considerations and best practices we need to keep in mind, such as number one, setting appropriate timeouts and threshold for failure detection like this. Secondly, implementing an automatic recovery mechanism to periodically check the health of the failing service. Finally, provide fallback or alternative behavior when circuit is open. Like I said, we can implement caching mechanism. I'm sure you will surely Be amazed when you see who is widely using the pattern in their system. There you go. Netflix is known for using the circuit breaker pattern in their microservice architecture. They have deployed a widely used library called Hystrix, which implements the circuit breaker pattern to handle service failures and provide fallback mechanisms. Let's check our progress for the last time. So, here is the question for you. Can we use circuit breaker pattern with ambassador pattern? Time already started. Poll is open. Time up. Cool, I can see 50-50 response like yes, 50% says yes, and 50% says maybe. Sounds interesting. Well, let's discuss a little bit. Like, it depends upon the situation. Say, in ambassador pattern, suppose we need to rely upon some specific or maybe some generic services or maybe some delegate services which requires continuous monitoring, then obviously we can use this circuit breaker pattern over there as a monitoring service in the traffic management system. But we may not use this, like this actually overwhelms the system. So it depends upon situation. So both the answers are correct. Let's move on to the next section, factors analysis. Till now, we have discussed and understood about four major cloud design patterns. And now the time is to compare those based upon some important factors. Before starting, let me tell you that we shall analyze these patterns in five major factors, starting from the purpose. Gateway aggregation simplifies access and management of multiple services by consolidating them into a single interface, right? Whereas Sidecar enhances individual services by offloading specific functionalities to the separate component. The ambassador pattern simplifies communication and load balancing between services by using separate proxy component. And circuit breaker handles failures and improves resilience in distributed systems by monitoring and managing calls to remote services. Functionality wise, gateway aggregation provides a unified entry point, request response transformation, and security enforcement, while Sidecar offers additional capabilities such as service discovery, logging, or monitoring to individual services. Unlike Sidecar, Ambassador Pattern handles protocol translations, traffic routing, and simplifies service communications. Where Circuit Breaker monitors remote service calls, trips, and redirects call to a fallback mechanism upon failures. Third one is location interaction, where they suits well. Gateway aggregation sits at the edge of the system and interacts directly with the clients that we have seen already, forwarding requests to the appropriate services. And Sidecar runs alongside individual services, typically in the same container, and interacted internally with the main service. Similarly, Ambassador Pattern operates as a separate proxy component between clients and services, handling communications and load balancing, while circuit breaker integrates within the client or service to monitor and manage remote service calls. Fourth point is impact on services after applying these patterns. Well, gateway aggregation pattern provides a simplified interface for clients, abstracts away service complexities, and allow for centralized management and control. Sidecar enhances functionalities of individual services without directly impacting their core implementation, whereas Ambassador simplifies communications between services. And Circuit Breaker improves fault tolerance, providing cascading failures and providing fallback mechanisms. The final one is deployment flexibility. Gateway aggregation pattern can be deployed as a standalone gateway or can be integrated into service meshes. Sidecar pattern allows for modular and containerized architectures where sidecar can be added, modified, or replaced independently. Ambassador pattern can be deployed as a separate component, providing flexibility in deployment options. And circuit breaker pattern requires integration within the client or service code. It actually limits the flexibility in the deployment options, right? So the point is, these patterns have distinct purposes and provide different benefits in the context of microservices architectures. Depending on the specific requirements and challenges of system, one or a combination of these patterns may be chosen to address the desired functionalities and improvements. That's all for today. We will address all the questions you have submitted. If you have any additional inquiries, please feel free to contact us using the provide contact details on the screen. Kindly note that a recorded version of this webinar will be made available on our website in approximately 1 week from now. We will also send an email to you with the link to access the webinar at your registered email ID. Thank you for your time. Have a great day ahead.